It's time to chill out and get ready for a mediocre Q&A live stream. If you're old enough, grab yourself your favorite adult beverage, and if you're not, stick with apple juice. Put your feet up and relax. If you have any questions, feel free to ask them in the chat. And now let's cue up the intro music. This live stream is brought to you by Heatcraft Refrigeration. Find out more about them at heatcraftrpd.com. Yo, what is up, everybody? Welcome to the HVACR videos live stream. Hopefully, everybody can hear me, and I'm sure the people in the chat will let me know because last week we had some problems. But does that really surprise anybody? Because I always screw things up. So, hello to everybody. Let me see who we've got in the chat right now. Awesome. Thank you. Right on. So we got lots of regulars in the chat. If you guys are watching on LinkedIn, Facebook, whatever it may be, YouTube, it's all good either way. It doesn't benefit me any differently on either platform. The one thing I will say is if you watch it on YouTube, there is a giant group of people that have a great conversation going on. There's a whole chat going in there. It's really cool. So again, either way, I see your comments either way. It's all good. I see my friend Taz Sutherland is in LinkedIn. How's it going, bud? We communicate every once in a while on social media, every once in a blue moon. So it's kind of cool to see some people that I recognize. So what is up? I should go buy ice cream, says Adam. I want to go buy ice cream. So this last weekend was my anniversary weekend. Spent time at home doing the house project, doing a little bit more here and there. It seems like I only get like basically 4 hours Saturday morning, 4 hours. I didn't actually work yesterday morning, but I worked for about 4 hours today doing attic work and stuff before it gets too hot up in the attic, finishing up some line set stuff, doing some control wiring. I'm definitely going overboard on my system, and you guys will see. I mean, you guys have probably already seen. If you don't already know, I'm replacing the air conditioner in my home, and I'm going about it a different way. So first off, Adam, my buddy in the chat right now, is the person that did the load calculation for me. I just gave him all the details, measured everything, give him all the specs. He helped by designing the system, coming up with the actual load calculation. He was using the quick model software, and then helped me to design the duct system and all that stuff. So we're slowly been installing things, and I've been running the line set, the thermostat wires. And again, I'm going way overboard. I know. I totally know. I'm a nut job when it comes to things. So I ran Unistrut all through my attic, did hard drawn ACR pipe, did transitions with soft copper and bent it from the transitions. So basically 20 foot up the wall of my house. Then I transitioned to a flat spot on the wall. So then I did a bent piece of pipe going to that. We're doing all press connections using the Zoomlock Max fittings all throughout the whole system. So it should be pretty cool. But then, like, when I say I'm going overboard, I totally ran shielded thermostat wire. Like, I know you probably don't have to do that, right? But in certain situations, shielded wire can get you out of a jam, right? Because it helps to eliminate any kind of interference that you might get. And especially on inverter systems that, you know, really need that good communication. And I have a fully communicating system that I'm installing. I'm installing a Carrier Infinity system at my house. And this is all, nothing's a secret. I'm installing a 2-ton Carrier Infinity. I'm downsizing from my existing unit. Oh my gosh, I'm getting blown up in the comments about why am I downsizing? Why the heck didn't I upsize it, right? Because my system was massively oversized. Okay. This house originally in the late 80s, early 90s was designed with a 3-ton system, but that was single pane windows. That was horrible insulation in the walls, lots of air leaks, you know, that kind of stuff, right? So over the years, this house has been upgraded. I moved into this house probably about, I don't know, maybe 12 years ago, 10 years ago, something like that. And I knew everything was oversized, but there'd already been a lot of work done to the house, right? To reduce the heat load on the house. There's a giant patio cover on the back of my house that completely blocks the afternoon sun from ever getting in any of the windows. That was huge, right? And then all the windows have been upgraded to double pane windows, vinyl, you know, whatever. And I've repaired a lot of the air leaks in the house, eliminating a lot of those issues. And with all of that work that's been done, we were able to downsize the system and properly size it. So I haven't started it up yet. Still doing work here and there, but just been doing a little bit of work on the weekends. So it's been consuming a lot of my time. But amidst that, like I kind of alluded to, it was my anniversary this weekend with my wife. We're celebrating 18 years as of yesterday of being married. We dated for probably 4 or 5 years before that. We met in high school. But the funny thing is that we actually didn't meet in the same high school. She went to the rival high school. We both lived in the same community, but we went to, you know, the rival high schools, and then we met through mutual friends and stuff. So we've been together for a very long time. So it was kind of nice to be able to celebrate that, and had a nice day yesterday. And then today, just working on the house project. Went and we have a friend that is into really getting into rodeo stuff, right? And so we went and watched him. He was at a roping competition today. So we went out there for a little while, somewhere local to us, and watched him. They were doing where they were roping the steers. They were double teaming it, where they had one person on the heels and one person on the head. And so it was pretty cool to watch that. Never seen something like that. So it was pretty neat. So I've had a good weekend. So hopefully you guys have had a good weekend. Hopefully you're enjoying your holiday if you're in the States. Today's a holiday for us. So it's very, very cool. So let's see what else we got going on in the chat. And then I'll get into something or a couple other things that I want to cover too. So let me see. Let's see. John L says Zoomlock Max, that much better. We still have the old jaws. I don't know what you're saying about that, but yeah, Sporlan used to be partnered with RLS. They're no longer partnered with RLS. RLS went on their own. We don't need to get into any of the drama, but RLS is now pushing their own product. Okay. So the original Zoomlock jaws were actually RLS jaws that Sporlan was marketing for them. So Sporlan separated from RLS. RLS started promoting their own stuff. So the original Zoomlock jaws are actually RLS jaws. Okay, now Sporlan is promoting another product, the Zoomlock Max, which requires new jaws. That's the product that I'm actually using on my home install. So let's see what else we got going on in here. Have I visited the Sporlan division in Missouri? No, I have not visited Sporlan in Missouri as of yet. I was actually supposed to go out there before the whole COVID drama started and everything. So hopefully we'll get to do something in the next year or so and get to go out there. That'll be really cool. You know, the interesting thing is that whatever. You guys don't need to know this, but I was actually born in Missouri. And a lot of the people that are in the marketing team with Sportland, I have met them, communicated with them for several years now. And it turns out that some of them actually have family members or know of the area that I used to live in. So it's kind of neat to be able to talk about like the hospital that I was born at and different things. So it's pretty neat. But anyways, a lot of useless information right there, right? Do I service mini split systems? I mean, not really. I've worked on them for a few customers here and there, but I don't work on them on a regular basis. Most of the equipment that I work on is package units. We do some traditional split systems. And then, in the past, over the years, we've had a few mini split systems. I probably have maybe 10 mini split systems out there in operation right now at my locations that I service. Really don't need a lot of maintenance other than just cleaning the filters really, and, replacing batteries every once in a blue moon. So, yeah, definitely. If I do make it out, we'll definitely be announcing it and everything. So that would be cool. Let me see. What else do we got going on in the chat? Okay, cool. Got a couple things I want to talk about too. So had a few videos that I released over the last couple weeks, as usual. Okay. The whole point of these live streams, the reason why I do these is because I release 2 videos a week on average. Okay. And I do a live stream and I get a lot of questions and emails and different things. And instead of answering every single email, every single question, I get a lot of repetitive ones. I try to answer those in a live format, and it's just a little bit easier for me. It saves my sanity of having to stare at my phone all day long. So I did have an email from someone, and I'm going to answer their question in the chat today, but I get quite a few people asking me, hey, how come I don't answer emails? How come I don't respond to the emails? And I'm not trying to offend anybody. The main issue is that on average, I get 5 to 6 emails probably a day of people asking me questions. And keep in mind that I'm running a normal refrigeration and air conditioning business. I have employees working for us and, managing that. And then I run an HVACR videos business, right? And having to deal with that and focus on, just the stuff that I have to do. And I'm very thankful for all of this, but then I have a family at home too. So, I can't always get to all the questions. And unfortunately, some of them go unanswered. So I try, I really do. And I apologize if I don't get to your guys' questions. Feel free to keep shooting emails and, eventually I'll probably get to it. But I will say the more technical questions are a little bit more difficult because if I have a really, really long day and someone asks me a question, I don't mind answering a quick question. Yes, no, a couple different things, a point here, a point there. But if someone goes into a really loaded question, it gets to be a little bit harder for me to answer. And I try to, but it still is time consuming. A lot of times when I answer emails and different things, it's in between jobs, it's at a stoplight, it's here, it's there. So then when I get to a question that's just fully loaded and it has all kinds of, it's just like, I can't, by the time I get home. So again, don't pity me for what I'm about to say, but on average, I work a full day, then I come home and I spend 3 to 4 hours a day editing videos on average. Okay. So I'm just constantly moving, constantly busy. So again, I try to get to your guys' questions. And if I don't, just keep sending them. I'll get to them eventually. Okay. So, why not when I'm on the roof, right? And I'm working in these really hot desert climates. Next thing, I work in Southern California. I live in Southern California. We have a lot of microclimates in Southern California. We can go, 25 miles, 30 miles to the ocean, and it can be on average in the summertime 80 degrees with like 60% relative humidity. Super nice days. Very rarely does it get above like 90 degrees at the beach. It does not get very hot. It gets cool in the wintertime in the 50s. We go to my area, the Inland Empire, which is kind of a mixture between desert climate, beach climate, and mountain climate. Okay. My area, it can get to 110 degrees, 115 degrees. The highest I've ever seen it at my house was 120 degrees, but that was literally for a couple hours in one day. Okay. We have very low humidity at my house. Then I can go to the actual desert region where they have a lot during the summertime. It's basically constantly above 100 degrees, usually pushing 120 degrees somewhere in there just all the time. Okay. My house, we don't get like, we might have, 40, maybe 20, maybe 25 to 30 above 100-degree days at my house during the summer. And then you have 90-degree days, but you go out to the desert climate and it's just insane, right? So I actually do some work out in the desert climate in the Coachella Valley, the low desert of Southern California. And when I do is usually some of the most extreme videos that I show when I'm working in 120-degree heat. And You know, a lot of people ask me questions and they have opinions about things that I should do. Those are also the videos I'm in the low desert when I'm posting about sand being everywhere and stuff. That's the low desert too. So one of the more common questions is, how come I don't set up an easy up? How come I don't have a misting system on the roof? How come I don't wear a cooling jacket? That kind of stuff. Okay. Really, the thing is that number one, I try not to be on the roof that long. Okay. When it comes to setting up canopies and easy ups and different things, sometimes I do. It is, you know, there is times that I will set up an easy up, but there's a lot of factors that go into that. When I'm working out in the desert, they oftentimes will have wind all the time. Having an easy up on the roof when it's windy is just a disaster waiting to happen, because the last thing I need is for me to focus on something else and not pay attention to the canopy and have it blow off and hit a customer or something like that, or hit someone's car, you know, down on the parking lot, like, you know, that kind of stuff. A misting system, that's just not practical when I'm working on a roof because of all the setup and everything you have to do to get it all set up and broken down when you're done. It's just not very practical for us. You know, I mean, in a perfect world, the customer has misting systems set up on the roof and we go up on the roof and we just open a valve and it shoots misting air everywhere. That would be great, but it's not practical. Nobody wants to pay for that. Okay. So it's really about practicality. When I go onto a roof, you know, the more stuff I have to bring up there, the harder that I have to work. You know, if I have to bring up tons of canopies and different things like that, you know, it can be a pain. Now, there has been times, right, when I've done some kind of work where I'm working on a desert roof for a very long time. Maybe I'm doing a crane lift or something like that. Like, I'll have the crane lift up ice chests. I've had them lift up water jugs, canopies, different things like that. If we're doing a lot of work, we'll do that. But, you know, just the amount of teardown that goes into a lot of that stuff makes it difficult. Okay. Great question that I had about the Appion core depressor. So Appion actually came out with some new core depressors about a year ago, something like that. And they are not core removers. They are core depressors. So they really, really shine when you are working on the high flow Schrader devices, the Cormax fittings. Okay. And so you can put this core depressor on there, screw it down, and it depresses the high flow Schrader. And then you don't have to worry about having a restriction from the gauges Schrader depressor trying to push the high flow Schrader down. Okay. So the question is, what do I think about Appion's new high flow Schrader depressors? I have them. They work great. One thing I will say, there is a flaw in the high flow Schrader depressors, or the Appion core depressors. I don't know what the name of them is, but the flaw is that, and it actually isn't in the tool, it's in the high flow Schrader. When you're depressing a Cormax fitting, you never want to fully depress it, because when you do, they get stuck. So if you're using the Schrader depressors from Appion or whoever else makes them, there's a bunch of different manufacturers. And basically you put it over the Schrader and then you screw a little knob and it pushes a little, you know, plunger down and pushes the Schrader in, right? You never want to screw that all the way down, because that high flow Schrader will get stuck. In fact, I had a standard Schrader get stuck using the Appion high flow Schrader depressor, right? Because you can use it on regular ones too. And it was depressed down too much and it got stuck. Like, it just happened. So just be careful about that. But other than that, they're great. So far, I haven't had any leaks, and I have pulled evacuations with them so far, but mine are still only like a year old or something. So they're not that old. But I have nothing but good things to say. If you're interested in checking out the new Appion high flow Schrader depressors, or Schrader depressors, whatever they call them, check out TrueTechTools.com. I do have an affiliate program set up with TrueTech Tools. If you use my offer code Big Picture on checkout, that's one word, you get an 8% discount on majority of the items they sell, and then I get a small commission from that. So it's a great way to help support the channel. So far, I like the Appion core depressors. Let's have a look at the chat and see what else. Let's see. Jason Johnson says he is not a fan of the Appion core removal tools, the CRTs. He says he uses the Navac one and they are so much better. That's really interesting, Jason. I have yet to use the Navac Schrader core removal tool. Haven't used it yet. I think I've seen it in a supply house, but I've always used the Appion ones or the True Blue ones, which are actually made by Yellow Jacket, but they're not the same as the normal Yellow Jacket core removal tool. So, but yeah, I haven't used the Navac ones yet. Brian Sanders, I'm gonna throw a bone to you, dude. Brian Sanders wants to know if I've ever farted in the bathtub and tried to bite the bubbles. Nope, I've never done it, Brian. Brian is really good at completely derailing me when I'm like in a zone and I'm focusing, and then I just happen to look over to the chat and then I read it and I'm like, oh, Brian asked good questions. And then I'm like, I'll read it out loud and then I'm like, wait, no, dang it. He's gotten me a few times, but Brian's a good dude. So let's see what else. Yeah, Jason Johnson, it seems like every Schrader removal tool that I've used has a hard time getting the Schraders out sometimes. It's kind of a pain. Sometimes you can't get them out. You have to like stick the Schrader tool in there, you know, and I know people will say you can adjust the little piece that grabs the Schraders. It doesn't matter. They still sometimes don't come out because the Schraders get damaged or the threads get damaged. It's just a pain. So every one of them has a problem. Lots of great people in the chat right now. Let's see what else we got going on in here. Okay. So Alex wants to know, oh, this is a great question. So Alex is currently about to have his system moved at his home. Okay. He's moving his existing condenser to another location. And when he has it moved, he wanted to know, he wants to have I'm assuming you're going to have someone else do it, Alex, from the way you phrase your question, but Alex wanted to know what size dryer to put in because he wanted to put in a Sporlan catch-all dryer. And he also wanted to know what size TXV to put in because he wanted to put in a Sporlan TXV. So, Alex, number one, if you're having another technician do it or another company do it, again, I don't know if you're a technician or not. You definitely want to make sure that they size everything correctly. Now, when it comes to the Sporlan expansion valves, you got the Sporlan Tech Bulletin 1010 right here, and this is going to tell you how to size the expansion valves. You can go to sporlan.com, look up, or just Google search Sporlan Tech Bulletin 1010. That's all you got to do. And it will come up with this. It tells people how to size the TXVs. Depending on what type of a TXV you have on your system, Sporlan does have universal chat lift connector TXVs where you can basically with 3 different TXV sizes, you can fit most systems. It's kind of like a balance port valve. Also, when it comes time to sizing the filter dryers, the catch-alls, you want to look up the Sporlan Tech Bulletin 40-10. So 40-10, and that's going to tell you how to size your dryers. Now, when it comes to sizing the dryers, for older systems, I personally suggest oversizing the dryers just a little bit. Typically on a residential system, if you can deal with it, you are going to have a little bit more refrigerant volume inside the dryer if you do upsize it. Get with like an 8 cubic inch or a 16 cubic inch Sporlan catch-all, and you should be pretty good, okay? But yeah, again, to preface that, he wanted to know how to size and select a TXV for his system, and that's going to be Sporlan Tech Bulletin 1010, and then for the catch-all dryers, Sporlan Tech Bulletin 40-10, okay? And those are both going to help you to dryers and the TXVs for your system. Human Rights wants to know what happens when your home AC is oversized and you need to install from a 2.5 from a 4-ton. Okay, so Human Rights, here's the thing. My home system is oversized, okay? So it really depends how your system was oversized. And I'm going to lump this into another question too, because I had another question right here. Let's see if I can find it really quick. It's already answered Alex's question. I have a list right in front of me right here that I'll cross off. So let's go down here. I'm trying to find this other question that I had that relates to the question right here. So why? Okay, yeah, basically it's just about oversizing equipment. So why is it that oversized equipment is so bad? I'm really curious for the people in the chat right now. Why is it that an oversized residential system can be bad? So let me know in the chat. What do you guys think? There's going to be a lot of variables that go into oversizing a system, and it's going to be climate specific. So depending on what climate you're in, there's going to be more problems or less problems depending on how your system is designed and how much it's oversized. It can lead to a lot of issues, okay? So I'm curious what the chat has to say about the issues that you can run into if you have an oversized residential air conditioning system. Okay, so I see one right now. Someone says short cycling. Okay. Someone says you can have humidity issues. Very good. Yes, those are all. Poor dehumidification. Yes, exactly. Okay. So depending on your climate, if you have an oversized system, the cycle times are not long enough to properly dehumidify the space that you're in, okay? You can also run into really high energy bills if your system is short cycling a lot. In the case of my house, I have a 4-ton system that was originally a 3-ton system, but I actually have a 2-ton cooling load, okay? So the cycle times on my system are not very long. my system turns on, runs for maybe 8 to 10 minutes, not even that, probably 8 to 9 minutes, then shuts off, then stays off for 20 minutes, then turns back on, runs for another 10 minutes, then turns back off. So the cycles per hour on my system are insane. And every time my system starts, we have a really high inrush current, and that leads to a higher than normal energy bill. Okay. But mainly you're going to have majority of the time dehumidification issues. Okay. So if your system's not running long enough to properly dehumidify your house, that can be an issue, but it's not as simple as that, because duct leakage comes into play. And, you know, I had someone asking me the other day, why in the heck am I worried about air sealing my fan coil unit, right? Because I'm installing a heat pump at my house. And I made a short form video a couple months back because I put a duct blaster measuring the air leakage on my existing fan coil before I installed it. And I taped it all up and I put the duct blaster on it, and I was showing that there was air leakage around the filter door of my fan coil. And, you know, I get a lot of people pushing back on that, saying it's not a big deal. That's a negligible amount. That's stupid to even be concerned about air leakage. I'm wasting time. I'm wasting money. I'm wasting their brain because they had to watch the video. Like, oh my gosh, the comments were insane. But air leakage is bad because air leakage is energy loss. Okay. So let's say that I have a fan coil that's installed in the conditioned space. In my house, when I am done, my new fan coil, my 2-ton heat pump fan coil, is going to technically be installed in the conditioned space. So why would I be concerned about air leakage on my fan coil? What's the big deal? Well, because I'm going so extreme with my home system design that I need every CFM of air that I can get out of that system to properly cool my house. Okay. And if I have air leakage inside a closet, it may still be in the conditioned space, meaning that the air is not going to go to the attic, right? So it's not going to try to cool the attic air, which is 150 degrees or whatever it is up there. So that's not a problem. It's going to be leaking into my house, but it may lead to comfort complaints, because if it's leaking out at the air handler, it's not being used in the system and it's not being delivered to a room. And we designed my system so tight, basically, that we need every CFM of air to get to every spot in every room. And we don't have a lot of fudge room in there. Okay. To be losing, you know, 10 CFM of air, 20 CFM, 50 CFM, 100 CFM, whatever it may be, we need that air to go to the places it needs to go. Okay. So oversizing your system can lead to a lot of issues, and it really is dependent on your situation, right? Because, you know, my house has nothing to do with the oversizing per se, but my house also has duct leakage, right? So we are blowing air into the attic from the supply side. So it's making my house negative. So that means that when my system, my current furnace and cooling coil system runs right now, the blower fan turns on and it sucks air in from the house, and then it doesn't get all that air through the ductwork because some of it leaks in the attic. So it makes my house negative. So then it draws air in through all the air leaks in the house and causes issues there too. Okay. So that's all going to affect. Now, when we have a system that is oversized, it doesn't have long cycle times, and we have air leakage on the supply side that's in the unconditioned space, like in my house, now it's drawing air because the house is going into a negative air pressure. Okay. So my existing system starts up, it blows air, a little bit leaks into the attic. Well, it doesn't make it back into the house. So then the house tries to find that air. So it draws it in from everywhere else, right? Think of the house as like a sealed duct. It's leaking the air out, so it's going to bring air back in. Well, that air is unconditioned. If I lived in a really humid climate, it would be drawing in unconditioned, humid air, adding to the latent load of my cooling load and causing issues. But then if I had short cycle times, it would be you know, it just leads to a giant dumpster fire of problems. So every bit of efficiency you can get out of your system, you know, the better, basically. Let's see, but isn't my thermostat really close to my return? Yes, technically my thermostat is close to my return, but we don't really have comfort cooling problems. So yeah, theoretically, I could move my thermostat far away from my return. Okay. But then it would be getting a temperature from somewhere else that would make it run longer cycle time. So yes, we could do that, but it's still oversized. Let's see what else. In my case, all right, let's see what we got going in the chat. What was my design temp? My design temp at my house in the summertime was 95 degrees, or it might have been 97 or 98. I can't remember. It was like 95 to 98. And then the design temperature for the heating load was 37 degrees. So, let's see. So it sounds like I watched the recent Measure Quick HVAC school video. Well, I haven't watched the recent Measure Quick HVAC school video yet, but I'm sure that it talks about everything that I just talked about. Am I going to cover the outside line set with sheet metal? I haven't decided yet, Delmar. That's not really a priority of mine right now. More or less just getting a proper install, and then I'll decide later if I want to cover up the line sets. Were those light fixtures on the side of my package unit on my recent videos helpful or useless? Light fixtures on the side of the pack. No, those are useless. They don't do anything for me. When I am brazing, I use an oxyacetylene torch when I'm brazing, okay? When I'm brazing the line sets together, doing whatever copper repair. What size tips do I use on my torch? I typically have 3 different size brazing tips that I have in my torch. I have a 0 tip, I have a number 2 tip, and I have a number 15 rosebud tip. Typically, when I'm working on reaching coolers or really, really small things, I'm going to use the 0 tip. Then I'll jump to the number 2 tip if I'm doing a little bit bigger. And then the rosebud is typically going to be when I'm brazing 7/8 inch and an eighth lines and I really want to do things quick. I'm not a huge fan of using the rosebud tip on like 3/8 and dryers and different things, but I have, and I can, I do every once in a while, but I prefer to use the smaller tips so you can control the flow of things. Another thing too, I get a lot of criticism, and it's fine. I totally understand. I am 100% open to criticism. If you guys have advice for me, if you think I'm doing something wrong, tell me about it. Okay. You can put it in the comments. I'm not afraid for other people to see it. You can put it on Facebook. You can put it in email. You can put it wherever. Okay. Let me know. I'm always looking to grow, and I'm always looking to become a better technician. Okay. So if you have feedback for me, give it to me, negative or positive. I'm totally open for it. Okay. So I get a lot of feedback about brazing, and people criticize me because my brazing, I use too much heat. I use too much solder. I don't control the heat correctly. I don't flow the solder correctly. I'm heating the wrong thing first. I'm heating this. I understand. Okay. I've never been to brazing school. Never once took a class on brazing. Okay. I learned from the School of Hard Knocks, just turning it on. I can remember being in high school, turning on a cutting torch, and my shop teacher teaching me how to use a cutting torch, and then I remember my dad teaching me how to use a brazing torch, and nothing has been actual education. Okay. I never once claimed to be the smartest person in the room. I'm not a perfect technician. Okay. But I do have some common sense when it comes to brazing too. Personally, I like using more solder than is needed. Okay. I really do. I like using more solder or brazing rod, whatever you want to call it, because I don't like seeing a shoulder. I don't like seeing a gap, even though I know it's probably sealed. I like the comfort of knowing that there's plenty of solder on there. I also encourage all my employees. I don't bitch at them about what kind of solder they use or how much they use. Just get it leak free. That's all that I'm concerned about. And don't overheat everything in doing so. Okay. But I certainly could probably benefit from going to some brazing classes or something like that. Sure. Whatever. But again, I'm still going to put too much solder no matter what I do, because it's comfort. It just makes me feel good. So I spend a couple extra pennies. I don't mind. Okay. Why not using a Bosch system for my home? Bosch was a contender in the thought process. I personally just wanted to go with the full inverter system that had full communication. So I decided to go with the Carrier Infinity. I don't doubt that I'm going to have problems with the Carrier Infinity, but I can tell you that I am doing the best within my abilities to install that system. Okay. I plan on following the manufacturer's instructions to a T, and then going above and beyond when it comes to the installation of the line set, proper piping practices, installation of components that help me to work on the system. I'm going to go pretty crazy. So you guys see what I do in some of my videos. I'm probably going to be instituting a lot of those commercial refrigeration practices when it comes to, and I know I am. Okay. I'm not going to reveal everything that I'm doing yet, but it'll be pretty common sense when you guys see how I installed the line set and what components I've put in the line set to help me to work on it in the future and different things. They're all going to be in this. So, and I plan on using the Zoom Lock Max press tool on as much of my install as absolutely possible. And I will say that I did some press fittings in the attic this last weekend, and game changer. Okay. Climbing in my attic into the horrible places that I was at, Saturday morning, and all the way across in my attic in a really confined space. If I had to drag a torch up there to braze this, it would have been a pain in the butt. And yes, I could have done it. Yes, I have done it. But hey, I have the Zoomlock Max press fittings. I used them. I pressed the fittings on, and I have confidence that there's no leaks and we're good to go. But it's all about prep. Am I going to seal the FAU closet? Yes, I do plan on air sealing the closet when I am done. So it will technically, by the time I'm done, be part of the conditioned space. So let me see what else we got going on in the chat. What am I missing here? Is there a concern of solder entering the joint? There is a concern of solder entering the piping, yes, but not the joint. The joint itself, I want to have solder in there. But yes, you want to make sure that you don't put so much solder that gets stuck into the pipe and, you know, can contaminate the system. Yeah, you want to make sure about that. Let me see. Reading through the chat right now. Jason is saying it's called insurance when you use too much solder. True. Very, very true. Okay. Reading through here. Just remember, pressure drop and velocity, very critical for any system. And when it comes to proper piping practices, you know, when it comes to refrigeration guys know this, and air conditioning install guys know this, and air conditioning technicians probably know this too. But there's two things that you need to be concerned about. Well, one main thing that you need to be concerned about when running a line set, when pipe fitting, okay? And that's total equivalent length. Total equivalent length is the measured length of the pipe accounting for, okay, the pressure drop that fittings create in the pipe. Okay, so total equivalent length is really what you need to be concerned about when you are piping a system. So my existing system, I can tell you, has 20, 40, has at least 60 feet of measured pipe length. Okay. But then I have to sit down and do the calculations for the total equivalent length. And that's when you take into account, you know, what a 45 equals. Okay. So basically they have a measurement that says a 45-degree fitting equals, you know, let's just throw a number out there, 6 feet of pipe. Okay. Or a 90-degree elbow equals 6 feet of pipe. So it's the equivalent of having a 6 foot long straight section of pipe with 190. Now that number is just an estimate. That's not necessarily true. It's going to change from each fitting size and the type of fitting that you use. Are you doing sweeping elbows, long radius elbows, short radius elbows? Those all come into play. So that's the kind of stuff that I'm taking into account when. Now, one of the things you run into when it comes to residential equipment is oftentimes manufacturers don't necessarily give you line set lengths accounting for total equivalent length. Okay. So, you know, the refrigeration equipment, they typically tell you that and you size the pipe accordingly, but you definitely want to lean on the manufacturer's instructions when you are sizing pipe. So, yeah, it does. Jason Johnson says that he remembers seeing a double suction riser for the first time. And then you read about it and it makes so much sense when you understand it. The first time you read about a double suction riser, you're like, wait, what? Wait, what? You know, like it's confusing. But then when you start understanding how they work, you know, it does make a little bit more sense. Okay. And it's basically on systems that have low capacity, it's basically going to fill one of the P traps in the double suction riser with oil, and it's basically going to allow the refrigerant to flow through one of the pipes. And then you know, when the velocity picks up, it's very interesting when you start reading about it. So definitely. Let me see. Am I doing line voltage monitoring for my Infinity systems? Yes, I have a voltage monitor surge protector on the indoor unit and a voltage monitor surge protector on the outdoor unit. So yes, I am doing it. Why does it matter to cool the upper part of a high ceiling room? Well, in my situation, I'm more or less just trying to get air across the rooms to try to follow the roof line to get across and down to the sides. Because we're using smaller supply registers, we're looking at more getting velocity, or the velocity of the air going out of the registers without making it too noisy. We're trying to shoot the air across the room so that it can mix with the air that's the furthest across the room. Clearly, we're going to have some issues, and I'm surprised nobody in the comments has said this yet, but something that we do have to account for is that since I put in a full inverter system, my indoor blower is going to ramp down. It's going to slow down. Okay. So there's going to be times when we're not going to get proper mixing in the room. And that's where we're really going to have to rely on ceiling fans. I have ceiling fans in almost every room in my house. So if we're running in a low capacity situation where we don't have a big load and it's ramped down to a lower speed, the air coming out of the vents and the registers is going to be a lot lower than if we had a high load situation, right? So then therefore the air is not going to be moving with the same amount of velocity as if it was in full cooling, right? So that's where ceiling fans really come into play with these fully communicating inverter systems that ramp up and, you know, speed up and slow down kind of a thing. So, but when it comes to that, yeah. So, all right. Let me see what else we got going on in the chat. Are they all 8-inch flex supplies? No, they are not. Everything changes. We have some 7 inches. We have some 6 inches. I think there might even be a 5-inch. There's a 9-inch. I mean, it all changes everywhere. So, am I wearing pants? Yes, I am wearing pants. Remember what live stream you're talking about. So I don't have a lot to say about this yet, but I do want to talk about something that I did get approval to go ahead and talk about this. I've had this sitting in my house for a while now. This looks huge, okay? And at first, when I saw this, I was like, why is that so big? This is an intelligent controller for a walk-in cooler, okay? But most people probably haven't seen this style of intelligent controller because it's in a weatherproof box. Why would it be in a weatherproof box? Because this is Heatcraft Refrigeration's universal, okay, intelligent controller that you can install on other evaporators that are not Heatcraft, okay? So when I first saw the box, I was like, that's too big, but actually it's not. When you really start breaking it down, there's plenty of room for the wires, and there is other manufacturers that make some of these, and the boxes are so small, it's hard to get all the wires into the back of the box when the conduit goes into the bottom and stuff. So this is their new universal intelligent controller. This can be used on electronic expansion valve systems and non-electronic expansion valve systems. So this is really cool, and it'll work with other electronic expansion valves too. So pretty cool. I will be using this in some videos in the future. Those videos won't be released for a while, but they have a pretty cool kit. That's not even released yet. That's not even for sale yet. So stay tuned. You'll be seeing about that here soon, right? Let me see. Am I using the big 4-inch filter or an electronic unit? I am using a media style air filter. MERV 13 is what I'm using, and it's going to be, is it 4 or is it 6 inches? It's a April Air media style filter. So, no more mounting to panels, that's for sure. Yeah, that's a big one, but that'll be nice because you don't like on some of the manufacturers when you use their universal controllers, there's no room for the wires when you get them inside. And I really appreciate that one because there's plenty of room to make all your connections and not have jammed wires behind it, worrying about shorting them out. Yeah, I believe it is complete NEMA for Jason Johnson. Here, hold on, let me look. Let me see what the specs have to say. So it's a full kit that comes with a box and everything, all the sensors and all that stuff. And let's see. Yeah, I'm not going to bore everybody with all the details right now, but stay tuned. You guys will see me using it in the future. So let's see what else. Anyone have thoughts on Smart AC? Smart AC is a bunch of like monitoring devices that go on your air conditioner. I have no opinion on it, never used it, so I don't know anything about it. Let me see. What microphone am I using? I am using a Rode Procaster for the microphone. So I've been using this particular one for probably 4 or 5 years now. They're great mics, very expensive, but very, very nice mics. So why did the filter dryer? So I had a video that I released last week, and it was a carrier package unit that had a plugged up filter dryer. So first and foremost, why did the filter dryer plug up? The system had not been worked on for years. It was the original compressor in the system. What the heck caused the filter dryer to plug up? Well, that particular customer does not do good routine maintenance. So in my opinion, what led to the filter dryer plugging up was a catastrophic system failure where the oil in the system is just completely destroyed, okay? Which also I did not address very well in the video, led me to the thought to go ahead and change the compressor. Judging by the look on the top of the compressor that the paint had completely melted off the top of the compressor and it started to rust, That to me tells me that there's a catastrophic failure inside that system. Now, the existing oil in the existing compressor is mineral oil. Okay, polyester oil, super easy to ruin that oil. Mineral oil is very forgiving. So it takes years and years of abuse to completely break down mineral oil to the point that it starts to plug up filter dryers and cause issues. So in this situation, the system, I put a new filter dryer and a new compressor in it. That system still has a very short lifespan. That system is on its way out. The customer really needs to consider replacing that. Okay. Why in that video that I released where I fixed the carrier package unit, changed the filter dryer, why did I put the original R22 back in, and why not go in with an alternative? The person that asked me the question specifically said 422D. Why not use 407C? Why not use MO99? Why not use insert name of whatever flavor of R22 replacement refrigerant there is out there? Personally, I have not had very good experience using alternatives to R22, especially on the carrier fixed orifice metering devices. Something about the fixed orifice metering devices, I've had a heck of a time with the alternative refrigerants, and I follow the instructions to a T. Okay. First off, I'm going to tell you out there, any refrigerant that is an R22 alternative that is meant to replace R22 with very minimal system replacements, they oftentimes will have deceptive marketing data that says that you don't need to do an oil change. But if you read the installation instructions for, I challenge you guys, let's put this out here. I challenge you guys to tell me or show me data from a manufacturer that says their refrigerant does not need an oil change, okay? That it works perfect with mineral oil. You show me that data, and I bet you anything, at the bottom of that data sheet, that's the instructions for that refrigerant, there's something in there that says in high pressure drop situations, we recommend polyester oil. In low load situations, we recommend polyester oil. We recommend installing crankcase heaters to help. Like they all have a bunch of stipulations, okay? The only refrigerant that really, really works well with mineral oil in air conditioning applications is R22 because it was designed for that specific application. Okay. Most other refrigerants are actually designed for polyester oil, but sometimes some of these refrigerant manufacturers will add certain components to the refrigerant mixtures. They'll add hydrocarbons, they'll add different things to try to make it work better, right? To make the mineral oil more miscible with the refrigerant so that way it travels better. But my personal experience is that R22 works the best with fixed orifice metering devices on these package units, especially when they're old beat up units. Okay. So I personally don't like using the alternatives. Now, I have with very good success used 407C with polyester oil on systems that have expansion valves. That's R22. I've had very good success with it. Okay. But fixed orifice metering devices, for some reason, I have a hard time with it. Maybe I'm doing something wrong. I don't know. All right. Let me see. Okie dokie. That's funny. Reading through the chat right now. Reading through, seeing whatever. You found out you can put 407C on top of R22, or you can use 410. Josh, I don't suggest doing that for anybody, okay? First off, you do not want to mix refrigerants, period. Okay. If you mix refrigerant, and it may have worked for you, no judgment. Okay. But if you mix refrigerants, you're setting up the next guy for failure. Okay. Because how's he going to know how much of what's the new refrigerant mixture? What pressure temperature chart do you follow? Okay. So let's just say this 407C, the pressure temperature relationship to R22, it's not very close. Okay. I'm looking at a 70-degree temperature for 407C. R22 is 121 121 psi, and for 407C it's 140 psi. Okay, but that's not like a linear scale that's going to constantly change. So it's not going to be a 20 psi difference all the way across the board. The next thing is 407C is a blended refrigerant. That means that there's multiple components that make that one refrigerant. R22 is a single component refrigerant. Okay, so I can tell you that R22 is going to have the same saturation temperature and nothing's going to change, right? But with the blended refrigerants, things can change. So when you start mixing R22 with a blended refrigerant, you are completely changing the chemical composition of that refrigerant. And who knows what's going to happen. Now, to be fair, I know, and I can guarantee you, there's a crap ton of people watching this right now that have mixed refrigerants and it works fine. Good on you. That's fine if it works for you. I just don't, because I don't want to set myself up, one of my employees up, or someone else up for failure. If you're willing to mix 407C with R22, who's to say the guy after you isn't willing to mix a flammable refrigerant with R22? You don't know. So let's just not go down that path. That's the way that I do it. But again, I'm not judging you for what you do or anything. Okay. It is what it is. So, yes. And the Glide is crazy with the replacement refrigerants for sure. 100% for sure. Can I please talk? And again, I'm not trying to attack anybody. I mentioned your name, that you said you mix them, and that's fine, dude. I didn't mean to. I don't want, I'm not into the drama game. Okay. So you do you, I'll do me. It's all good, man. I'm not offended at all. So hopefully you don't get offended. Where am I draining my condensate pipe with all my other pretty lines down the wall? Dale Mar, my condensate for my existing home system actually runs under my slab and comes up. So it goes under my slab and comes out on the other side of my house. So I'm going to continue to use the existing condensate drain for now until it becomes a problem. Then I would run something else. So let me see what else we got going on in here. Okay, so why not install on the system that I was just talking about, the carrier unit that had a plugged up dryer? Why did I not install a suction filter dryer? Because I changed the compressor. The new system's going to have polyester oil in it. I can pretty much guarantee you, if I install the suction filter dryer, that suction filter dryer is going to plug up. I can pretty much guarantee you, because that system's probably trashed already. It had mineral oil before. I put a new compressor in that has polyester oil. That polyester oil is going to go through the system, and even the new dryer is probably going to plug up. So in a perfect world, the customer has me go out in about a month, check the pressure drop across the dryer, replace it, but they're not going to. They're just going to let the system die. So it really is just comes to do with the customer. Let's see. Am I putting air pressure gauges on my system so I can see what's going on apart from being cool and nerdy? I'm not going to put fixed gauges on my system. I'm not going to do that, but you know, that is a cool thought. I don't think I'm going to really have the space to do that kind of work. But I am using a Carrier Infinity system, so I technically would be able to access my system parameters and vitals just from my phone, being able to pull it up on an app and look at anything that's going on within my system. Let me see what else. Why charge through the high side? So when I start up a system and I'm done making the repairs, I've pulled in evacuation, we've changed the dryer, and we're getting ready to charge it up. Why do I charge on the high side first versus just putting refrigerant in through the low side? And let's add some more to this question. Why is it that I charge with liquid refrigerant on everything that I'm doing? Okay. So first and foremost, old school days, they told you don't ever charge with liquid refrigerant. You're going to ruin a compressor. You're going to slug it. You're going to ruin the valves. Okay. That was overhype. Okay. Older systems were a little more susceptible to refrigerant issues when it comes to flooding back or charging with liquid, but honestly, that was more hype than anything. Okay. The industry was taught, don't ever charge with liquid refrigerant because you'll ruin the compressor. Okay. As long as you're metering it and you're not just dumping it in on the low side, you're going to be fine. Okay. But when I do an initial startup, why do I charge from the high side first? Simply because I don't have time to charge through the low side. And if you charge through the low side, you charge with liquid refrigerant through the low side before it's running, you typically want to leave it in an off cycle for an extended period of time to make sure that you don't have liquid refrigerant building up in the compressor in pockets and different things. So you just want to let the system stabilize out. So instead, what I do is I charge in through the high side, dump as much gas through the high side with the system not running until it won't take any more. Then I shut it off. Typically, the gauges are probably equalized out by now. The refrigerant's gone through the system, the natural flow, and I can turn it on and then charge, metering the refrigerant through the low side. Okay, so I'm not dumping liquid in anymore. I'm just open, close, a little bit at a time, putting it in. So there's nothing wrong that's going to happen as long as you let the system properly stabilize out. You're going to be good to go. Okay. But there's a lot of hype about don't put liquid refrigerant in the system. I'm not saying dump just pure liquid into a system when it's running, but there's a little more precaution in there than the reality of you causing a severe problem just by simply getting a little bit of liquid refrigerant. But again, I'm saying don't just open it and just let it dump in through the low side. So, all right, let's see what the chat has to say real quick. See what I'm missing. What is my opinion on Beacon 2 systems? Adam, honestly, I don't work on any Beacon 2 systems. I work on Heatcraft's QRC systems, and I work on the intelligence systems, which is kind of the predecessor. The QRC was the quick response controller. That was the budget predecessor to the Beacon 2. And then the intelligent is the new replacement for Beacon 2, basically. But I don't have anything bad to say really about Beacon 2 because I never really did a lot of work on it. So, see what else. On large commercial systems, it is known as a compressor killer. Maybe in smaller systems, it's okay. We've had horrible oil return experiences with it. I'm assuming he's probably talking about MO99 would be my question. I bet you anything that's what Jason's talking about. Why wouldn't someone install? Oh, great. Joe, why in the heck would someone install a solenoid valve on a split system AC? So I'm going to put that one to the chat right now. Anybody that's in the chat right now, I want to know. Why would you install a liquid line solenoid valve on a residential AC system? Okay. And spoiler alert, manufacturer's instructions specifically tell you to do this in certain instances. In fact, I very well may have to install a liquid line solenoid valve on my own 2-ton system that I am installing in my home right now. I was just reading through the manufacturer's instructions and I looked at something and I was like, oh, I might have to install a solenoid valve on my system. So let's see okay, prevent liquid migration. Let me see what else. Let's see what people have to say. Oil return issues. Yep, that's exactly it. Long line set applications. Okay, so here's the deal. When you have long line set applications, you have added refrigerant to the system. And there's instances where that refrigerant can migrate to other parts of the system depending on the temperature, right? And then on startup, it can cause issues. You can have, issues with the refrigerant coming back all at once, washing out the oil out of the compressor. So in long line set applications on residential systems, most manufacturers are going to have something in their installation instructions that say you need to have a liquid line solenoid valve installed. So I'm putting a Carrier Infinity system on mine. And there's specific terminals to hook up a liquid line solenoid valve on my system. Okay. There's a very good possibility because I believe that Carrier said line sets over 70 or 80 feet total equivalent length need a liquid line solenoid valve. And I know for a fact that I have 50 or 60 feet, at least 60 feet of measured length on my line set, with a few 90s and 45. So there's a very good possibility I could be hitting that limitation where I might have to install a liquid line solenoid valve on my 2-ton residential system following the manufacturer's instructions. So that's why it's long line set applications. All right. Reading through the chat. Okay. Why go through the hassle of patching the old supply diffusers in my home? Why not use the existing ones? So I'm sizing a new air conditioner for my house and I'm using new supply diffusers. You guys can't see it, but I have a new one cut into my office. My last video, HVACR videos, house project part 4, I think is what it was called. I released where I was cutting in the registers in a couple different rooms. And I cut in new registers in every room because my new home system design requires a smaller system, and we need to have basically different size ducts, different size registers to try to help with the load and get air mixing properly, right? So why not just use my old ones? Because I didn't want to have to patch over anything. I wanted to just cut in new holes. And in the bedrooms, in majority of the bedrooms, I'm going to utilize I plan on utilizing the existing supply registers, and we're going to turn them into transfer grills to dump the air into the hallway to alleviate some of the pressure issues because we don't have proper return path for the air that's delivered into the rooms. Okay. But basically, I just don't want to have to deal with trying to patch half a register. Why not use the existing registers and just deal with the sizes? Because I wanted to get crazy on my system install and do everything as best to the, by the book as much as possible. So, because I'm a nut job. Okay. I could have gotten away with, just downsizing and dealing with what I had. It probably would have worked, but I'm just kind of crazy. So let's see what else. What we got in here. Reading out in the chat right now, see what I'm missing. Reading through. J.R. Smith says Coke knows. Yep. Coke nose is when my nose hairs get so long they touch my mustache hairs and then they itch like crazy. Yes. Leonard and Edgar both asked for tips for a new HVACR tech. Like what advice do I have for new HVACR service technicians? The advice that I have is number one, always try to better yourself. Don't give up learning. Okay. You will never stop learning in this trade. There's always something new. The more knowledge you have, the more you are worth. The better technician you will be, the more knowledge you have. Okay. So don't stop learning when you leave work. Go home, research. If you have a few minutes, get on social media, go to like the HVAC school Facebook group, go to the HVAC overtime Facebook group, go to whatever niche you want to work in, right? You do kitchen work, there's kitchen HVAC groups. There's all kinds of information, but don't just utilize Facebook as a resource. Go on YouTube, do research, go to manufacturers' websites, read installation manuals. When you're on a roof and you see a piece of equipment that you don't understand, if you can do so, and the reason why I say this, there's some customers that you're not allowed to take pictures at, but if you can do this, take pictures of the equipment, find the data tags, do research on it, figure out how it works, figure out what it is, okay? When you're on a roof, and this goes for every technician, but especially the newer guys, when you're on a roof, don't wear headphones, don't listen to music unless they're being used as like a hearing protection thing, okay? When you're on the roof, listen to the equipment. You'll learn how the equipment's supposed to operate and what it's supposed to sound like if you can actually hear it running, okay? I'm not saying that I never have music on a roof. If I'm working on a roof for an extended period of time, I might put a job site radio up there. Make sure it's not too loud that the customers are going to hear it down on the ground level, okay? But I typically don't wear headphones unless I'm using them for hearing protection because I want to be able to hear things on the roof. I want to be working on the air conditioner I'm on and hear the exhaust fan across the roof, making weird noises. So that way I can go to the customer and be like, hey, I was on the roof working on your AC. Your exhaust fan sounds like it might have a bad bearing. You may want to put in a work order. Guess what? I just generated work for the company and I didn't rip the customer off at all. I found a problem and told the customer about it before they potentially had downtime. Okay. So those are a couple pieces of advice. Constantly better yourself, learn, and don't necessarily put headphones in your ears when you're working on the roof. That way you can actually hear the equipment you're working on. Okay. Those are a couple pieces. Let's see what else we got going on in the chat. Is performing a load calculation a good niche to pursue as a future career? Okay, so I am not an expert at doing load calculations. I have the smallest amount of experience. I've done a few on my own, and I realized that those were even oversized. Okay, trust the math. Make sure you're using Manual J, you're following what they say, okay, and make sure you're doing research. Don't just trust an app to tell you what's going on. You need to have knowledge. Pursuing load calculations as a career, okay, is going to be difficult. I will tell you that right now, because right now we're in a time where customers want everything for free. And there's a lot of contractors out there that are doing load calculations as kind of a loss leader, and they're giving away way too much information. To do a proper load calculation on a house actually requires a site visit. Okay. I know that doesn't sound practical, but a site visit is crucial for doing a proper load calculation, okay? Because you need to see what is going on. You can't just trust someone that says the house measures this to that, or the house is this many square feet, you size it. That doesn't always work, okay? A proper load calculation, and I know this is extreme, but a proper load calculation should always include a blower door too, blower door test. So that way you know what the air leakage is. And you should probably do a duct blaster test to find out what the duct leakage is too, because if you're not replacing the ductwork and you're doing a load calculation on the house and they have really leaky ductwork, and you're sizing to the actual BTUs that the load calculation says, well, you're probably going to run into a problem because they're losing energy in the attic or wherever the ductwork's running, and it's not getting to the place that it's supposed to. Okay. So can you pursue load calculations as a new career? Yeah, I'm sure you could. You'd have to find the right niche to work in, and you have to be able to make money. Okay. And you're going to be competing with a lot of these companies right now. Like there's companies out there that are using artificial intelligence to do load calculations. They're hiring people that know nothing about HVAC and they're teaching them how to input numbers into a computer system and then push print. And then they're just selling those load calculations at a discounted rate to people. So it's a very interesting market to get into. Yes, you can make money if you do it right, but you really need to know your stuff for sure. How much do companies charge for a blower door test, commercial or residential? Really, that's going to depend. I don't know those numbers, but I know a good majority of people don't charge enough for a blower door test. When you think about the investment, if you're about to go drop $5,000 to $8,000 on a fancy blower door setup, right, with dual fans or who knows what, and then you're going to go out there and charge $40 for a blower door test, like that's going to take a long time to get your investment back on that blower door. Okay. And it's not just as simple as putting a blower door on a house and saying, oh yeah, you have a leaky house. Like you need to go dig into it and find out where the air leakage is too, and be able to help the customer to say, you have air leakage all over the place. Your money would be best spent fixing this or fixing that, and you'll get the best bang for your buck. But I don't know the exact numbers of what people are charging for blower doors. So the thing is, will the contractor trust a third-party load calculation? It really depends, right? So it really depends. All right. Why use a circuit tracer to find a 115 volt breaker versus shorting it out? So I did a short form video a while back where I was using a Klein circuit tracer to find a breaker for an exhaust fan. And boy, did I get my butt handed to me with negative feedback on that one, because I'm a dork, because I didn't just take that 115 volt wire and touch it to ground to short it out to find the breaker that way. I wasted the customer's money because I put a device on there and used a tool to find the circuit. And why am I doing that? Why am I showing that to technicians? These are some of the things that I heard. Okay. Here's the deal. Taking a wire and shorting it to ground on purpose can be dangerous. Not necessarily always, but it can be dangerous if the wrong person does it. What happens if a breaker doesn't trip? Have you ever had that? I have. Have you ever had something short to ground and you could just hear the wire in the conduit bouncing around? I have. Okay. Have you ever had a situation where a breaker didn't trip? I have. It's not good. It leads to bad things. I've had bad experiences with breakers not tripping, causing mains to trip, causing big issues. Okay. Plus, add to that, you have so much technology in these buildings now with, circuit boards and inverters and microprocessors on cooking equipment and all kinds of stuff that you don't need to be shorting a wire to ground purposefully, okay? Because you can cause damage, you can cause issues. So in my opinion, you shouldn't be shorting anything to ground if you don't have to. You should be using tools to find those things. I get it. I probably could have taken that wire and shorted it to ground and tripped the breaker, and it probably wouldn't have been a big deal, okay? But we got to try to do better. We can't just always assume everything's going to be okay. I'm a pessimist. Assume the worst so you're never disappointed. That's my motto. And I know that can lead down so many problems and lead to so many issues. But if I think of the worst case situation and I always assume that's going to happen, you're never going to be disappointed. You really aren't. Because guess what? You assume that it's going to be the worst case, and most of the time it's not going to be. So, okay. Let's see what else. Yes, go ahead and show up at $100 million building in short breakers to find a unit. That'll be the last time you're ever allowed in that building. 100%, 100%, man. 100%. It's just sometimes, right? Why am I I already answered that question. Cool. Right on. I already answered that one, knocked it off the list. Justin asked about soft starters. Justin is thinking about installing, I think, a micro air soft starter on his existing system, or no. Justin asked because he's an electrician, if I remember right. And someone asked him to install a soft starter. First off, the micro, whatever that thing is, I got nothing bad to say about it, but it's not technically a soft starter. I don't know what you call it, because it does something weird where it slowly limits voltage going to the system. Like, it's kind of weird. There's a bunch of voodoo magic that happens inside of it, but the theory is that it's going to reduce the starting current, the inrush current, on your system, and slowly ramp it up to full speed, and not just have that energy spike when you turn your compressor on. Okay. What do I think about them? I mean, I don't have anything bad to say about those soft starting devices, other than, I mean, don't you think that the manufacturer of that compressor would be making one of those? Which, in theory, I have heard that Copeland Compressors has thought about making those devices to try to start their compressors. But don't you think the compressor manufacturer would be manufacturing those things in mass quantities if they really wanted them on their compressors? That's just a thought of mine. Okay. But I also understand that innovation creates things sometimes that manufacturers haven't decided to start making on their own yet, you know? But I'm a little leery about some of those devices because the manufacturer doesn't recommend them per se. So it's like, is that really a good thing? But I mean, is it an old system? Does it reduce the life of the system? Maybe. I don't know. I don't have enough data to say that it's actually a good or a bad thing. So let me see what else we got going on in here. Okay, I already answered that one. Really curious what advice I have about brazing copper-coated stainless steel valves. So I'm assuming you're talking about Danfoss has them, and a couple other manufacturers have copper-coated stainless steel valves. Okay, so when you're doing a copper-coated valve, it's stainless steel and it has a copper coating. There's a whole different process. And what you typically want to do is heat the pipe up first. You heat the pipe up, not the valve, and you get the solder to flow on the pipe right before the valve. And then you just take your heat and you draw the solder into the valve and just go all the way around. You don't have to use flux on those if they're copper coated. Now, I've had pretty bad experience with most refrigerator manufacturers that use copper coated stainless valves with them leaking. I really have had a lot of bad luck with them, and I follow the manufacturer's instructions to a T. But it's interesting though, because I don't necessarily have those problems when I'm working on non-reaching cooler type systems. So it could be about environment and different things like that. When I'm working on ice machines that have copper coated stainless valves, I have nothing but good success with them. So, but really the it's about controlling the heat, which direction it's flowing, getting the solder to flow on the pipe itself first, and then drawing the solder into the valve. That way you don't overheat the valves. That's going to be the biggest trick that you have in those. See what else we got going on in here. HVACR School had a video on soft starters. Seems like people are still skeptical about them. Yeah, that I was a little skeptical about that video too, because it's a lot of manufacturers saying that it does this, it does that, and not a lot of third-party data saying that it actually works. So that's why I'm a little reluctant about some of those devices. But I have no experience. They may be the greatest thing since sliced bread. I just haven't used them. So let's see what else. What else we got? Reading through here right now. All right, which circuit tracer am I using? I have a really, really cheapy Klein one. It's not very good. It gives a lot of false alarms. And I know that you're supposed to run the entire panel before you use it. When I posted a short form video, I got so much feedback because I said it gave me a false alarm and didn't get it. That's after I ran the entire panel like 2 times. No, I ran the panel once, then ran down. It told me one breaker. It wasn't that one. Then it told me another breaker. I followed the instructions. They're just, I don't know. I can definitely buy a higher end one that'll work a lot better. But yeah, I just haven't had the need to because I don't use them that much. So, all right. Well, that is it, guys. It is time for dinner. We are going to be going out with the family tonight, going out to a food hall near us where they are going to have music, and we'll get to go to, I don't know if you guys have these food halls, but it's like a giant cafeteria style place that has a bunch of different restaurants. They're usually like mom and pop restaurants, and you can choose between them, and then they have common seating areas and stuff. So we're going to go to one of those tonight. So it'll be nice. But yeah, I do really appreciate you all. Thank you so very much. Remember to check out the HVAC Overtime Show Friday evenings about 6:05 p.m. Pacific time. I do it with my friends, Adam, Bill, and Joe. And we do a fun show. It is a not safe for work show. It is completely uncensored. It is the polar opposite of this channel. So check it out, HVAC Overtime on YouTube, okay, Friday evenings. I'm going to go ahead and cue up the outro music if I can actually figure this out. And yes, let's see. Let me go ahead and do this real quick. There we go. And I will go ahead and cue up the outro music. I really do appreciate you guys, and we will catch you on the next one.